Hello guys, this is the third set of Jones Notes. This is Unit 7, Lesson 3, which is about electric charge. So let's go ahead and define it. So electric charge, which is a vocab word, so I'm going to highlight underneath. So an electric charge is a property, and remember this is a field, just like gravity, so it acts at a distance. It doesn't have to be touching. It can be, but it doesn't have to be. So a property that leads to electromagnetic interactions. Okay, so what that means is that it's going to lead to like a repulsion or attraction force. So let's go over that. So if I have an atom or an object with a positive charge, and I have an object with a negative charge, these two objects, let's say they were balloons hanging on a string. So these are opposites. So opposites would actually attract to one another. Okay, so opposites attract is a main idea. Opposites attract. And then if I had, let's say, balloons again on a string, and they were both negative, or we had balloons on a string and they were both positive, when you have the same charge, they will actually go away from each other, which is called repelling. So same charges repel. Okay, so opposites attract and same charges repel. So you guys will find that those examples you guys have hopefully learned before. So opposites attract, same charges repel. That is the main idea. Now, you might ask why an object has more of a positive charge or why an object has more of a negative charge. So it's just electrically charged that way based on the atoms within. So for example, if I have an atom that has protons and there are 5 protons in the nucleus, and the electrons that are floating around, maybe these all have negative charges. So let's say that there are 4 electrons, there are only 4. Protons, there are 5, which protons are positive, electrons are negative. So if I have 5 positive and 4 negative, then this one would have an overall charge of a 1, and it would be positive because there's 1 extra proton than there are electrons. So this is something that's more in the 9th grade Ohio standards, which is more knowing why something has an electric charge. So for those of you who remember me teaching this, which this was all the way back in September when we learned about this, but we remembered that there's actually a word. So if you have what we would call a positive ion versus a negative ion, so when I say positive or negative, I mean that overall charge. So if it's positive, we would call that a cation. And if it's a negative, we would call that an anion. So that's just a little bit of some extra information. I don't know if anybody remembers this, but I remember that the plus sign looks like the T in cation. And anion, some people were talking about how the negative looks like the line that goes through the A. So if that's a way for you to remember it, that works super well. So this would be a cation and an anion. This would be 2 anions, and this would be 2 cations. So that's a little bit of some 9th grade stuff for you. but I noticed a lot of you guys have been asking me about that in general. So that is the electric charge beginner steps. So I'm going to move on a little bit. So when we're talking about electric fields, so when we were talking about gravity in the last video, we talked about the two things it depends on. But electric fields depend on different things. So it depends on two main things. So what you'll find is when you are talking about fields, obviously distance is huge. Talking about how far away the objects that are not in contact, where they act at a distance, that's huge. And then also the charge. The charge meaning, is it positive or is it negative? Or it could be neutral, or have no charge. So we would need to look at that. So when we are looking at the charges, this is when we're talking about if they're going to repel or attract. And the distance, obviously when they're further apart, the field is not as strong. So a longer distance is a weaker field. Okay, so that's just the two things that it depends on. We have three ways that they can interact. So I'm just going to go over these. This is something that you've probably learned maybe in like 6th or 7th grade in Ohio. But a real quick little review. We have friction, so you can convert the charge while they're touching. And then we have something, and that's when they're moving. Then we have contact. And then the last one I'm going to talk about is what we call induction. Okay, so we're going to talk about these three real quick. So these three are some main ideas. So friction is when the objects are rubbed together. Okay, objects are rubbed together, where contact just literally means that the objects are touching. And we can move electric fields through any of these three. Okay, it's not just a field that acts at a distance, it can also be touching and converting that charge. Induction means that they are not touching. Okay, not touching, but they still can attract. They still attract or repel things. Okay, so they would be not touching, but they could still make things move. The next page, I'm just going to talk about materials for a second. So I'm going to flip it. Again, feel free if I'm going too fast to pause it to catch up or replay the video. But we're going to talk about materials real quick. Okay, there are three main materials when we're talking about which ones would affect the charge. So we have one that we call conductors. Okay, we have one called insulator. And then we have semiconductors. Okay, so conductors, insulators, and semiconductors. So these are all materials that can move the charge, okay? So conductors, the charges move freely. Okay, so that would be things like metal, for example, like copper. Okay, an insulator would be when they don't move freely, so the charges do not move freely. So an example of that would be like plastic. Oop, I can't spell today at all. Plastic, rubber, things like that. Things that insulate. Obviously, sometimes we want conductors, but sometimes we want insulators. So you guys know how I love my coffee. I want my cups to have insulation on them because I don't want the heat. Now I'm talking thermal energy, not necessarily charges. But I want things that will keep it from moving. So it's very similar when we're talking about conductors and insulators in materials in terms of thermal energy or heat and electric charge. So anyways, semiconductors are right in the middle. So it's more of a controlled flow where conductors, they're moving very fast and very quickly. Semiconductors, they're more of a controlled flow of charge. Okay, so what that means is that it's a certain pace that the charges can move between it. One of the main ones that they use, especially in like the technology field, is silicon. Some people say silicone, it just depends. But those are good semiconductors, which is why they use silicon in things like computers, chips, phone chips, things like that. So again, that is our electric charge lesson. If you have questions, comments, or concerns, please write them in the area below. Again, I'm also on my email, so if you have specific questions that you want me to see a little quicker, feel free to email me anything that you need. Hang in there. You guys are awesome. I hope to see you guys soon. I'm going to continue with the next couple lessons for Unit 7, and then I will kind of take your guys' opinion on what unit to do next that we're maybe struggling on. Have a wonderful day. Bye.